Okay, so we're going to start with matrices. So as we are going to recall, a matrix is a rectangular array of numbers. So what that means is we have these square brackets with what we will have numbers inside them, or they can have letters. It doesn't have to be just numbers. And what we call, so we have the square brackets, and we have the numbers or the letters inside are called elements. So if you have a look at this one has 6 elements. Okay, we often need to talk about the order of a matrix. So an order is where we say the rows by columns. Okay, so in this example, this one has 2 rows. And the columns are up here, so it has 1, 2, 3. So this one you do rows when you comment on the order, you say rows first. So this one is a 2 by 3. So sort of like a photograph. When you say you've got a 2 by 2 inch by 3 inch or whatever photograph, it's a 2 by 3. You do need that multiplication sign when you say the order. So can you see how I did little curled brackets and wrote a 2 by 3? You must write it like that, okay, when you're talking about the order. Now, the order is important because it tells us whether we can do certain operations. So you can only add and subtract matrices if they have the same order, and we'll learn later on about when we multiply a matrix by another matrix, there has to be certain conditions in the order. Okay, so we're talking down here, and this is the a bit that people find a little bit tricky in the exam style questions. So each element in a matrix is identified by its row column and its row number, and its column number. So what they happen to call the row, they symbolize if you're talking about the row number, they call it the I. So say this element up here, number 2, I would equal 1 because it's in row 1, okay? And when they talk about the column, they often say, they refer to it as the J number. So if you talked about this number 2 up here, the J would also be 1 because it's in column 1. Column 1. So if I did another example, say this one's I would equal 2 because it's in row 2. And what would its J equal? 3. Good. So that's what you're going to do. So they'll always use these letters I and J. They'll say let I represent the row number, and they'll say let J represent the column number. And then you'll get a few questions. So, and this is what I'm going to do is this question with you. So it says A is a 2 by 2 matrix where the element in row I and column J. So they'll just say that. All they're saying is they're going to let I equal the row number and J equal the column number is given by. So what they're doing is they're creating a little formula for you. So this is a formula created to work out what the elements are. Okay, so for example, so when they want me to construct this matrix A, so what I'm going to do is, so they want me to call it matrix A, so often we just write the little symbol like that. Now it's going to be a 2 by 2. Now I'm going to exaggerate, I'm going to make it a pretty big, just so we can work it out. So we've got over here, we'd have row 1, and I'm going to say row 2 because it's a 2 by 2. So then I'm also going to have column 1 and column 2. Okay, so what we're going to see is, because it's a 2 by 2, we're going to see 4 elements in there. Okay? So we'll see 4 elements. Now, they want me, the way I create is to use the element is to use that rule. So over here, just above it, what would this spot's I number equal? if it was in that top left-hand corner, what would its I equal? 1. And what would its J equal? 1. Good. And what over here, what would this one's I equal? 1. And what would its J equal? 2. Good. And down here, this one, because it's in row 2, its I equals 2 and J equals 1. And in this one, I equals 2 and J equals 2. So what I can do is I'm going to use this formula. They're saying the way I work out the element is I use the formula I plus J. So in this first one up here, I equals 1 and J equals 1. So what would the element be? It'd be 1 plus 1, which equals 2. Okay, over here, because this one would have been 1 plus 1. Okay, if I use the formula for this one, it would be 1 plus 2. What's 1 plus 2? 3. So the element is 3. What would this one down the bottom left-hand corner would be? 3. Yes. And what would this one be? 4. Okay, so that's me really slowing it down so that you can work it out. What they do is they give you a lot. The formulas can be a little bit more involved than just adding them together. I'm just going to do a couple of examiner questions just to warm us up for matrices. So it says 2 subjects, biology and chemistry, are offered in the first year of university science course. Matrix N is the number of students enrolled in each subject. Then it says Matrix P lists the proportion of these students expected to be awarded an A, B, C, D, E grade in the subject. So proportion means when you change a percentage to a decimal, okay? So that's what proportion means. So you can see how, if I said that, what percentage of people got A? If I asked you that, what are you going to say? Yeah. What percentage of people got an E? Yeah. So that I'm just helping you understand what they're talking about there. Anyway, it says write down. We just got some basic questions first. Write down the order of P. So here's matrix P. What's the order of that one? How many rows is it? And how many columns is it? So it's a 1 by 5. And explain what the element P13. So when you see this, the first letter indicates what row you need to go to, and the second letter indicates what column you need to go to. So there's only one row in P, so I go row 1 and column P. So explain what the matrix, what that element means. What does that element mean? It's a C, and it had 0.7175. So what did I say that could be interpreted as? Yeah, so we could say it 17.5% received. Is that how you spell received? Received, or is it expected? Sorry. Yep. 17.5 expected to get a C, yeah? A grade of C. Okay, so when they ask you to interpret the element, you can't just write it down. Even if you wrote, if you could have written 0.17 were expected to get, that's okay. You know, you can just write the proportion. But just as long as you explain what it is, you can't just write the number. You've got to say what it is. So we were saying we're going to get a grade of C. So that you're showing that you understand what they're talking about. Okay. In the calculator here, it just shows you how to get up the matrices. Hopefully you all know that. But you click on that button here, which is to the side of the number keys, and then you get your choices. These ones are quick ones, so you've got a 2 by 2, a 1 by 2, and a 2 by 1. If you hit them, you get them automatically. If you hit this big one there, you get to pick which, like what you need, how many rows, and then off you go. That's all you need to know. I don't really find the need to have to store them. You might, if you have to, it's just like once you've got it there, you can go up and just copy it and like highlight it and drop it down. That I believe is quicker. So, but if you want to store them at any time, you can. I think it just gets confusing. I'd rather visually see what the actual matrix is. If you need help, just sing out and I'll help you to calculate a bit quicker. All right, we have a couple of types of matrices. So you just need to know in case they say display this data in a row matrix. So a row matrix simply is one row, and a column matrix is simply, one column. Okay, so you can see you've got the one column going down there. A square matrix is the same amount of rows as columns. So you can see they've done a 2 by 2, but I could say, if I do a 3 by 3, that's also, I just made that one up, that's also a square matrix. Okay, so a diagonal matrix, if you look here, is you only have numbers on that, what we call the leading diagonal. The leading diagonal, so you can see the leading is when you start up in the top corner, left-hand corner, and you finished and you got down there, that's the leading diagonal. So if you've only got numbers on that and zeros everywhere else, that's a diagonal matrix. Okay, a triangular, we've got two types. Obviously an upper, can you see the numbers are like a triangle in the top half? And then if you have a lower triangle matrix. So that's what a triangle matrix is, but what else could I call this one? It looks like it's a square, isn't it, as well? So you could describe it as a square. If you forget, you don't need to worry because you've got a little summary sheet here, yeah? So if they ask you to describe and you can't remember which way, which one's an upper, which one's a lower, we've got our notes to refer to. Okay. Now, we can be asked to transpose a matrix. Now, be careful because it's probably not really coming up. When they ask you to transpose a matrix, you'll have your matrix, so I'm making this one up. Okay, and they'll put a little T, yeah? So transpose, they put a little T there. And transpose simply means to make the columns rows, okay? And so you change it round. So if I was transposing this one, so the columns become a row. So I would have 2, 1, and 4, 6. So I've transposed it there. So you can see we've got another example down here. They've got that, and you can see these rows became columns. Yeah. So, and that's a transpose. So you just need to know, and you'll get a little T. So it's a little power T there, and they ask you to transpose it. Pretty easy. You just transpose it, change it around. Okay, so here's a question. This was taken off an exam, and it's question 1. So you know how we like to give a nice easy one. So what's the answer to this one? Matrix M is, what's the order of this one, just while we're practicing? What's the order? 3 by 2. So if I transpose it, it's actually going to be a 2 by 3. It swaps, yeah? So which one is the answer to this one? Sorry? D, yeah? Is it D? Yeah. So it's D. All right. Okay, a symmetric matrix. So this could be something definitely it could come up, I'm not saying it will, but it could come up in a SAC or something where you end up with a matrix. So can you see that this part in a symmetric, it'll be a square, and it's like you've put a mirror down the center and you have like the mirror image in the triangular part. So you can see how if you have a look, 6 is way out in the corner on both sides. So a symmetric one is it patterns out like that. What do you notice about an identity matrix? How would you say, what are you noticing about that? What type of matrix is it? It is symmetric, exactly. It could be symmetric, it's square, and it's also a diagonal, isn't it? The only difference with this one is what are the numbers on the diagonal? Yeah, they're all ones. So sometimes too, if you might want to write a little note, an identity matrix is like a number 1 in matrices. Acts like a number 1 in matrices. And what I mean by that, and we'll see a bit later, if I have, and we often call the identity matrix I, so if I had a matrix A and I multiplied it by an identity matrix, what I end up with is the A. It's just A. And as I'm saying, because it acts like a number 1, if I did 3 times 1, do I still get 3? Yeah? And that's what I'm saying. So an identity matrix can be like a number 1. It doesn't affect the value of the other matrix when you multiply it. Okay, a null matrix just has zeros, and we can only say that two matrices are equal if they look exactly the same. So you can see down here, these two have the same order. They're a 2 by 2, and their elements are exactly in the same spot and the same number. Okay, so they're only equal if they're exactly the same. Okay, so I'm gonna leave these questions. I want you guys to give them a go, and I'll go over them the next lesson, but you can also do 10A. Okay, so with this one, it says the order of matrix X is a 3 by 2. So you know you're going to have 3 rows, 2 columns. So try to get rid of what you know is wrong. So that one's definitely wrong. And it says the rule for creating the element is your I plus J. So that pretty much means you add the row and the column number. So remember, I equals your row numbers. So here on this side, I would equal 1, 2, and 3. And then J is your column, so that'd be 1 and 2. So if you add those two numbers together, what do you get? Now, you know row 1 plus column 1 would have to be 2. So I'm going to get rid of this one and this one because it has to be a 2. And then have a look at what's different with these, and I can see that this number is different. So I'm going to test that one. So if you look at this element here, I equals 2 and J equals 2. So I plus J would equal 2 plus 2, which equals 4. So this is the answer. Okay, so with this one, they're giving you the matrix, and now you have to find the rule that would determine this one. So what they're saying is you can find every element by going 4 minus the column number. So if you think, because this is J, and J would equal 1, 2, and 3. So 4 minus 1 gives 3, 4 minus 2 gives 2, and 4 minus 3 equals 1. That works. What about in the column here? Wouldn't we have exactly the same numbers along the second row if we use that first formula? Yes, we would. Yeah, so this guy is out. So we're not going to say this. This would produce the same one. So you're going to have to trial and error. You can either produce what the matrix is and see which one matches, or test them. So I might now convert. I'm going to do answer B. Using this rule, I'm going to create a 2 by 3. So I would equal 1, I would equal 2. Oh, sorry, we just want a 2 by 3. And here J would equal 1, J would equal 2, and J would equal 3. So if I was using this rule, I go 2 times I plus J. So this one would be 2 times 1 plus 1. That would be 3. Then I do 2 times 2, which would be 4, plus 1. That would equal 5. Already, that is not what's up there, so I'm getting rid of that one. So now I'm going to go to C. And I'm going to do the same thing. I'm going to try and create it. I equals 1, I equals 2, J equals 1, J equals 2, J equals 3. So the rule was you add the 2, I and J, and then also add 1. So this one would be 1 plus 1 plus 1, that's 3. 1 plus 2 is 3, plus another one is 4. So is that, no, that's not giving already, that's wrong. So I'm out. I'll try D. So I'll do the same thing again. So I equals 1, I equals 2, J equals 1, J equals 2, J equals 3. So I'm trying the D formula. It's I plus 2 of the J's. So it'd be 1 plus 2 times 1, so that would be 3. And then it'd be 1 plus 2 times 2, which would be 4. That would be 5. Does that one work? No. Just to me a pain. It's going to be the last one, because that's the last one I tested. Okay, and hopefully, does this E1 work? Hopefully it does, because otherwise I've done it wrong. Okay, so 2 times I minus J plus 2. So 2 times 1 is 2, minus 1 is 1, plus 2 is 3. That works. Now I've got 2 times I. So when I'm doing this one, it'll be 2 times 1, which is 2, minus 2 is 0, plus 2 is 2. And you can see I'm going to get it, so I'm going to say yes, that one works. And I would stop here, move on, and then at the end of my exam, if I've got time, I'll check that the rule works for all the other elements.